Welcome to the Beyond Einstein podcast. I'd like to thank our guest Larsh Johnson for coming down. Larsh is one of my oldest, smartest friends, best friends. We were business partners in the tech industry for 30 plus years.
30 long years.
30 long years. I was the sales guy, Larsh was the brains, and it worked out great. Nice complement of skill sets. But conversation here today is going to be very different than automating electric utility distribution systems. I had an epiphany years and years ago, a series of epiphanies that brought me a understanding of a way to integrate consciousness and metaphysics in with a physical platform to describe the universe. And these were epiphanies that happened typically at 2 a.m. I'd get up, I'd have to write stuff down, and over a 30-year period, dozens and dozens of these moments of clarity. In 2008, I got an entire unified theory of physics that allowed us to begin talking about consciousness and things. So I shared that with Larsh years ago.
I will say, though, I didn't know the half of, 30 years of working with this guy, and I didn't know the half of what you were doing in your spare time.
I wasn't working very hard.
Well, apparently, but I mean, we had a great time working together. But I literally, we talked about all sorts of things, but this was not a topic that we ever got that deep into. So while you were doing this, I was more than unaware of some of the stuff that you've been doing. So very impressed.
Yeah, Larsh is an engineer by trade and by education, mechanical engineer, I believe. Back before computer science was an actual class in SCIA.
But I would have to say my first computer science was punch cards.
Yeah, so was mine. Tape. I did ask you a bunch of questions, but they would be specific in areas that had to do with science, but we never talked about the sort of the overriding, which I didn't know was happening until fairly late. But had the series of epiphanies and came up with something that was very pleasing to me, and both from a physics standpoint and also from a reiteration of consciousness and metaphysics. My contention here is that Einstein made a mistake, first principles error. That mistake has been compounded dozens and dozens of times over the last 100 years, and has put us in a position where the model we use to describe the universe is illogical, it is overly complicated, it conflicts with itself, and that is the result of first principles omission. And if you correct that, then you can have a unified theory of physics that is far broader than what we have today.
The thing has always been intriguing, when we did start talking about this several years ago now, the question, that you've posed is the we don't know, the answer to we don't know, which is so many things start to get down to that answer in the end as you really dig deeper. And the fundamentals of gravity, and you've mentioned magnetism recently, come back to this idea that we're not really sure exactly how those things actually work, which are so fundamental.
Yeah.
And that's just really fascinating.
And that's the result of an error. They would find things that they could not explain. And the biggest cop-out is they would identify as a fundamental force. We know in physics that nothing moves without some type of energy transaction. Yet the foundation of both large-scale physics and small-scale physics are completely dependent upon fundamental forces. And that is a cop-out that has to be removed from the model.
Well, I always said physics is basically the science or the art of explaining things that we observe in the physical universe. So it's basically trying to come up with something that makes all these things, describable either with mathematics or with language. And so if you're a physicist, your job is to try to explain. And at some point, there's it's like the little kid asking why, right? You keep asking why, and it's like, in the end, it comes down to, well, we're not sure, or we don't know. Even though there's a lot of other things that describe and very carefully document the behavior under certain conditions of matter, energy, and so forth. In the end, some of those fundamental questions, like how does gravity work, are kind of like fundamental, and still we don't know.
Yeah, and then again, nobody's looking for other answers, or very few people are. Nobody in the mainstream is looking for answers. People seem very satisfied with, hey, it's a fundamental force. We have several different descriptions of gravity. Einstein had large-scale gravity, the bending space-time. And we have local gravity, which is a fundamental force. And then the quantum physicists have what do they call it? Gravitons. They had little particles that go out and pull things together. So it's a complete mess. And you're absolutely right. If you push a physicist and have him answer questions and he doesn't bail on you, he will ultimately come up and say, we don't know, which is perfectly fine. But it's a theory. The theory should at least be explainable. And it's not today. And it's not acceptable. And it has to change. And I think that we're stuck doing things that we shouldn't be doing based on flawed theory. And that is expensive. We are educating the next generation with a flawed theory, which cripples their problem-solving capability.
Well, it keeps people in the box, right? And if the box has been formulated in a certain way, and you're bringing new people into that box, they're going to basically see the same boundaries that they were trained in, right?
Yeah.
And I think that your goal here is to try to get people to think outside of that box on the first principles basis and say, how do we go about doing something with the idea that this box may not exist the way we thought of it?
And if we can do that, I think we can begin to have some breakthroughs in areas that we've been frustrated with for
now. You're talking my lane, okay? And that the engineering is kind of the art of taking the physics definitions of things and then applying them to real problems. And I think what we're doing now in engineering across all sorts of disciplines is to really push the boundaries of physics, smaller and smaller, more granular and more granular. And I think it's in material science and fuels, it's in even the electronics and circuitry we use all the time. All those things are very fundamental. And I think the engineering, one of the things that could happen if this sort of remove the box thing happens is that some of the things that I would look at from an engineer would actually be fundamentally different.
You could explain them. And I think you could do the same thing from a biologist standpoint, chemist
Absolutely.
standpoint. Yeah. So what we've done is we've answered a very simple question. The challenge was, how do you explain how an atom works without using fundamental forces? We know every atom in the universe does work. We know that for a fact. That's something we actually test and watch. Where does the energy come from that allows that to happen? And that the thought experiment is so simple. It comes down to this. It is simple. If you have to define an energy source, theorize an energy source, there is only one possible answer. And that is, it has to come from vacuum space. We have to reestablish an ether. We have to identify its properties correctly. It has energy-based properties. And that energy interacts with matter. And if you do that one change, you add back an ether energy, which is something Tesla told us we should do, which is something Einstein said we could not have a model without an ether back in 1920. If you put it back in, identify it properly, you have a unified theory of physics without the need of fundamental forces. You get rid of things like the Big Bang, expanding universe, dark energy, dark matter.
Yeah. And when you say get rid of them, basically you have an alternate explanation for what we're observing that makes current physics seek to say, I'll explain that by this concept.
Right.
And we already see that changing, right?
Yeah.
I mean, the latest telescopes are showing that maybe there's conflicting data, right? And it says, hey, this isn't necessarily happening the way we thought it was. And you read that kind of press all the time.
Yeah. And what's interesting about you talking about the expanding universe and what's happening with some of the high-end non-terrestrial based telescopes. Even Edwin Hubble at the end of his career said it's a static universe, and there's no evidence that there was a Big Bang.
Yeah.
The guy who's credited with saying with the redshift observation back in the 1930s studied his entire career and said, hey, it's not right. But the people who come out and say things that are not consistent with the status quo basically get censored. They don't make it into the papers. The entire physics industry is set up to protect the status quo.
Yeah. Well, it's like any institution, right? No matter what it is, it's basically it's a self-perpetuating organism, and they're going to do everything they can to keep a status quo.
Yeah.
And that makes perfect sense. You understand that, and we see that all the time in almost every field. But breaking that up, that disruption is something it's essential.
Yeah. Well, physics needs it right now, and the problem it has is it is self-perpetuating, as you said. We educate the next generation the same things that we were educated in. Then you spend 40 years of your career based on your education. If it turns out your education was wrong, you're in trouble. Your career is.
You see the same thing in large corporations and in the whole field of startups. That creative destruction is a theme, and large companies today are trying very hard, usually failing, to have their own internal creative disruption, so that they don't get dinosaured like so many industries. And I think you have the same fundamental problem here, except you have an academic basis, and academic institutions have a lot less of those kinds of dynamics.
And the physics industry does not have competition to drive change. It needs to change internally, and it is a self-policing institution. And the guys who are in charge have the guys who have the most to lose. If it does change, they will protect it, and they have protected it. And at some point, that has to change for us to begin making progress again. And I think that if we can provide an alternate theory that answers all of the observations that we've seen over the last forever equally well with what we've got today, that is more simple and more complete than what we get today, we will have a different roadmap.
We would call it elegance. We need an elegant solution that is not as convoluted as the current solution. It's built on the house of cards that you postulated started back in the original 20s.
Yeah. And I think that if we can do that, the challenge is that the guys who are responsible for communicating any type of change in the industry are the guys that are most resistant to change in the industry.
Yeah.
Change has to happen outside of the industry. Smart people need to begin asking questions. And when you get to the point with the questions that when you say why for the fourth time, digging down, and they say, I don't know, that's not acceptable. It's unacceptable.
Or you get that bright mind that says, I don't want to just say that. I want to go find out the real why. I want the real answer. At least peel the onion one more layer.
So I know a bunch of guys who did that. They were drummed out of the physics business. You don't get your PhD in physics if you do that. The interesting thing about physics education is different than most educations, is that it does not encourage critical thinking. The physics education is memorize and repeat. You don't get a good grade in physics by questioning some of the basic fundamentals of the industry. So all the guys that are questioning the fundamentals through the education process end up working for somebody else in the private sector. They don't get their PhD. And you end up with the guys that you have there running the industry as guys that consume the Kool-Aid.
Yeah.
They believe all this stuff.
Yeah, and I guess there's a lot of the theoretical physics that sort of set the foundation for the experimentation that is trying to prove those experimentally what those theoretical physicists came up with. And that's, I think, part of the problem, because you get your PhD by working on proving that theoretical construct, with an experiment.
Yeah, I've termed that defensive physics. We're no longer doing offensive physics. Everything we're
That's
doing,
good. I like that.
Everything we're doing is trying to validate a flawed, in my opinion, a flawed model.
Yeah, defending the status, defending the theories that are, sort of the institutional, momentum is propagating. Yeah.
So one example I've been using is we made an observation, an actual scientific observation back in the 50s, that the Andromeda galaxy, finally got the technology to see it, was spinning too quickly and defied Einstein's gravitational theory. And this has happened dozens of times. So at that point, there's a decision to make. Oops, Einstein, we have proof that Einstein's gravitational theory is incorrect or incomplete. So you can either say, hey, let's go back and try to figure out what it is, what gravity is. Or the second option they have is to discover something that would make the gravitational mathematics work.
Yeah.
They went out and changed the construct of the universe, and plugged in dark matter. And now we're spending billions of dollars looking for dark matter with zero success based on trying to defend a flawed gravitational theory that Einstein stuck us with 100 years ago.
Yeah, well, I think that's the basics of physics is, again, explaining those observations. And so if there's an observation and it doesn't fit your mathematical model, then you have to add something to that mathematical model. Plug variables, we used to call these things in various ways, and you basically plug in something and say, hey, that makes it work.
So something I find really interesting, I've spent a lot of time with physicists in the last 10 years, is that every physicist you talk to, particularly after a couple of glasses of wine, will admit we need a paradigm shift. We need a significant change. We're spinning our wheels. How you get there is a painful process. They don't really want to do it. But the exciting thing is that if we're right, the opportunity for progress is almost unlimited. And the whole world, all the theories that we have right now trying to explain things that just don't seem to really make sense, can go away. It can be replaced with logic. Less mathematics, more logic. I think that would be a big contribution.
Yeah, I think, and I think there's so many things going on in physics now, and also just in science generally. In the energy business, I've been in electrical power business now since you dragging into this space over
Apologize.
almost 40 years ago. But I think there's so much going on right now with the need to try to generate more power for things like AI and so forth. But fusion and small nuclear fission reactors have been a huge part of the news cycle lately, and fall because of this need for more power. And I think the promise of fusion has always been an exciting one because of all of the supposed characteristics of fusion versus fission for creating unlimited energy. And I guess I'm curious what you think about that, because this is back to the basics of physics being required to really say, what is it? How does it work? And is it going to be what we think it is?
I think the micro fission reactors are the way to go. Absolute perfect way to go. Yes, there's some waste. There are ways to deal with the waste. We spent 50 years trying to find nuclear fusion on Earth based on prior theory that the sun's luminosity is based on fusion reaction, which is wrong. Nuclear fusion is a net neutral energy transaction. It's a conversion of kinetic energy into nuclear energy. And it happens under extraordinary conditions of temperature and pressure deep inside of large objects. If we can create the environment where there's that much temperature and pressure to do it here, you'll be a net neutral. So, it's an example of flawed theory sending us in a direction for 50 years, looking for something that doesn't exist.
Well, certainly, I think latest news is suggesting that maybe there was some break-even energy coming out of this after I don't know how many billions of dollars have been spent on trying to get the stable reaction that will generate net energy.
Yeah, it's like every other, the nuclear fission is breaking up the molecular bonding inside of unstable elements, and it's a release of energy from nuclear back to kinetic, and then we use that then to spin turbines and create electricity. It's not going to work that way for fusion. Now, we can continue to look for it. You're not going to find anything. It's another one of those things where the amount of money and resources have been buried looking for things that don't exist is mind-boggling.
Well, I think this would be a really interesting area to say, well, what if, the things that you're postulating here, about the alternative approach, right? Being outside of that box, how would you apply that to the work that's being done in fusion? And be interesting to see somebody pick that up and try to take that forward.
And my hope is that through these conversations, we can reach that someone, that brilliant young kid or that disenfranchised physicist from 20 years ago, and say, hey, here's an opportunity to look for things in a different place. And they're a lot smarter than I am. There's a very good chance that they're going to think of something. How do we convert non-physical energy into physical energy? We see it happening all around us, but how do we harness that? The problem we have today is because it's outside of the existing theoretical box, nobody's looking for it, nor will they look for it unless the dissatisfaction with the status quo gets great enough.
Yeah.
Our hope is, we're poking the bear. And then enough guys like you, smart guys like you, begin asking questions.
Yeah, I'm not sure I'm smart enough to think through some of the implications of an alternative theory here, but I think the fundamentals of these kinds of processes are everywhere. I think right now there's just so much going on in the venture world or the investment world. It's called deep science or deep tech, and there is just a lot of money going into it right now because we have fundamental needs that we're not meeting. So it would be fascinating to see people decide that they want to approach this without adding the confinement of that box.
Yeah, and I think that if you use if you use this as a paradigm moment to rethink a lot of the things that are happening, it will have major impacts in areas like chemistry and biology and geology. A lot of other things, answering questions that are now completely unanswered. There are answers, and the answers are based on logic. When something happens and it goes wrong, and you're in charge of the status quo in physics, the last line of defense is mathematicians. We talked about plug theories. They will figure out how to make the math work. Right? It makes no sense whatsoever, but as long as the math works, hey, we're okay.
Well, the math may work, but then trying to describe what that math actually means is where you get these things that, as you said, defy some logic that would otherwise be flawed.
The first one of these things, big boo-boo, was in 1927 when they plugged quantum into described small, relativity fatal to small level. Plug quantum in. It's a mathematical tool. It's probabilities, mathematics. It doesn't explain anything. Einstein pointed that out, and Bohr and Planck and those guys said, it doesn't need to describe anything. And off we went. And that was the first giant plug. And that's when they should have turned around and said, oops.
Well, not necessarily say oops, but just say, look, we want to pursue multiple paths on this because this one doesn't necessarily explain everything. It doesn't, you said earlier, something to the effect that there was a theory that wasn't complete as opposed to wrong. And I think that's a good way to think about it. If the theory that isn't complete, rather than plug it, maybe reevaluate, that first principle set that was used to create that theory in the first place.
I'm gonna argue it's wrong. It's wrong because of the omission. Gravity is not the bending of space-time. Those are not mergeable things. Are completely separate, at least at this dimensional level. There was an experiment done in the late 1800s where Michaelis and Morley in Cleveland, Ohio, tested Newtonian's model of a static ether, that the Earth was moving through an ether. And they discovered it was not moving through an ether. They concluded that there was no ether. And that went into Einstein's thought experiment in 1905. Einstein loved ether. He wanted to do his thesis, graduate thesis, on the effects of ether and electromagnetism. And his professor said no. So Einstein brilliantly came up with a model that would work without an ether. Unfortunately, it's wrong. We're stuck with it. If Einstein hadn't existed and we expanded off of Maxwell and we paid more attention to Tesla, we'd be so much better off today than we are. Tesla was close. If the guy had any personality at all, he could have supplanted Einstein. Unfortunately, he was his own worst enemy. But he was brilliant. He wanted ether energy. He wanted to put it back in there.
Well, I think at this point, we're also looking back at those times and suggesting that if we were to follow that path, right, rather than following another path, that we might be better off. But I think that just goes back to the idea that you have to have multiple paths, right? Great, and I think take multiple paths forward from where we are now is I think the end goal.
Yeah, and that is one of the things that needs to change institutionally in the physics world. You've got to be able to support multiple paths. And that's going to require fundamental changes in how it's governed. Yeah. And, how that happens, God only knows.
Well, I think this is the disruptive piece of it, right? Because you have to be able to find people who are willing to get outside that box and think about it. And those people need to be able to spend time working, which is funding, and all those things that go along with the institution that is in place today versus an alternative institution, right?
if you look at the things that we're spending money, I'll tell you the big science. You know, the xenon lab is looking for dark matter. The super collider is looking for the next great particle. All of the things that we're doing in the astrophysics area with the telescopes. So much of that is being wasted, and we've had so many years of getting nothing out of it. But nobody's willing to raise the white flag because there are thousands of people working in those industries that don't want to lose their job.
And I maybe don't just entirely agree with that, but I think, the point is that you're making experiments. Those experiments include observing, the constellations from, Hubble Webb Lab and observations fantastic. Right. So those are observations. So I think the question now is more about the interpretation. And then also, how do you direct further observations, right? Because those two things go hand in glove. Same thing with particle colliders and so forth, right? What observation are you trying to make? And then how do you behave after you make that observation and your interpretation? Is it really something that's driving you to that next level?
Yeah, I think the super colliders is a great example of misguided physics. What the research physicists have done is spectacular. What they've done at the the Hubble telescope level is spectacular. Our ability to observe the universe is, think how much better it is today than it was back in 1905. Einstein went to the office on a horse and buggy. Things have changed. We know a lot more now than we knew then. We shouldn't be expecting them to do right. But the super colliders and all of the theories they have are based off of the core model. They're limited by the core model. And they're looking for things to validate the core model. They've had things invalidate the core model, but they sort of twisted them around so they continue on the...
Well, that's why it would be interesting to say, can you, in any way, repurpose some of that spend in the alternative path, without, and I think institutionally that's probably very, very hard or impossible, but I think that would be the interesting thing. And, the side product of all of these things has been engineering work that has actually proven to be remarkably useful. So I think it goes across the board. But I think in the end, if you're focusing that primary investment towards something, maybe it could be directed a little differently to explore, multiple different alternatives.
Agree. And I think that, the amazing things that they've done, the physicists have done over the years, with the model that they've had to guide them, is spectacular. And a lot of that was just by chance. We discovered something that was not predicted. But our theorists had stuck to their guns. They will not deviate. It seems like they're not even taking information in to respond to it. Everything is, how do we maintain status quo? How do we keep on path? How do we make sure that Einstein was right? And that isn't science.
Yeah.
They know that the thing's failed repeatedly, but they just keep band-aiding it together.
Oh, this is, when we were talking earlier, I think some of the things that I look at now and things that are going on in the, sort of the use of that sort of activity in terms of chemistry, in terms of physical and material science, energy transformation, generation, and so forth, all of those things, semiconductor processing, right? We're talking about nanometers of line width on chips on the road. It's crazy. And what all these things are doing are they're getting closer and closer to those basic physical interaction properties between different molecules, electron flows, activation energies. And, these are all just very important elements to almost all of that science that's going on right now. And I think it would be just remarkable if some of this would actually be broken through if there was
it would be really interesting to have some of the guys in the cutting edge, particularly in the micro level, view the world through a different lens, through a different theoretical lens,
right,
and see how that changes things. How would you behave differently? From the biology standpoint, if you look at the relationship, the energy relationship inside each subcellular system, the mitochondria, and you look at it with a slightly different view, you're going to come up with some big breakthroughs that could extend life indefinitely. But they need the latitude to think outside of the existing paradigm.
Yeah.
And that just isn't done today.
I think it is probably something that has to happen at the core physics level, because that can translate to the chemistry side of the equation and the electromechanical and so forth. That I think it sort of builds off of that. But it's interesting to think about, when you are in one of these fields and you're approaching what you might feel are basic minutes of the physics, to say, well, maybe not, right? Let's go figure out another way around that problem.
So you brought up something earlier about the conflict in theories about molecular bonding. The chemists view the sort of atom basically the old Bohr model, where electrons orbit.
That's what I always think, yeah.
Physicists have discovered electrons don't orbit. In the new model, the NIMS model, they jump from point to point inside of the electron field. But we're teaching our chemists something that we know is not true from the physics side. Okay. There's a problem there. Those two things need to be working out. They're merged, and we begin to look at molecular bonding slightly differently, or as field sharing. Maybe there's some huge breakthroughs they can have in energy.
That's exactly the way I would think about right now. If I were entering this field, or I were in this field today, I would be wondering, is this somehow transforming, what I used to think or how I used to behave, or going outside that field. And one of the things, this back to the, some core principles about, entrepreneurial settings and so forth, diversity in thought is a really good thing. And I think having everybody from the very same background doesn't give you the rich experience of having this kind of interaction. It sounds like physics and chemistry are in that stage right now.
What's interesting about the physics, if you look at the definitions of education versus indoctrination, education encourages critical thinking. Question the core principles, question the foundation. The problem we have right now in physics, and probably chemistry also, I'm not as familiar with it, is that there is no room for questioning. This is how it works. This is the platform you build off of. Now go ahead and build. Which is great, because if that platform's wrong, then all these guys are being set off into the weeds, and they're not going to be productive. And I think it's perfectly clear, again, if you talk to the physicists, that something is seriously wrong. Now,
we don't know.
And they've been trying for 100 years. Einstein led the charge to try to unify a unified theory of physics. He spent the majority of his career trying to fix the mistake. He wouldn't have called it a mistake, but trying to fix the problem.
Yeah.
And we've been looking to do the whole Higgs boson thing was supposed to be the particle that tied it all together and made it all make sense. The Higgs boson was nothing more than a funding opportunity for particle physicists. It's ridiculous. Now it's sort of forget about that. Particle physics has run its course. Now the new shiny object is string theory. It's a disaster, but it's a gift that we'll keep on giving, because you can't ever prove it right or wrong. It's pure theoretical. It's creative writing class for really bright physicists.
Yeah, and I have to admit, I feel very little about that, but I certainly heard the concept and understand how it is being driven through the quantum communities and so forth.
It morphs. Everybody you talk to is slightly different. It's morphing, real time. But that's not that again is a byproduct of having to deal off of a house of cards core theoretical platform. It should have fallen years ago. It should have fallen when they discovered that there were proton neutron inside of a nucleus of an atom, and they should have repelled each other. The protons should have repelled each other. But they plug in strong force. It happens over and over and over again.
Right.
And every time it happens, it's like death by 1,000 cuts. Yeah, that's not that bad. Okay, I kind of understand that. You educate the next generation that that's real.
Right.
And now it's real. It goes to the textbooks.
So I guess the part of the question is what are some of the foundational thoughts that are going to start creating those alternatives that we need to have people thinking about, right? So there's an alternative approach to thinking through all of these different pieces, the physics problems.
Each one of the illogical, what I would consider illogical conclusions and theories that they've provided, if you look through a different lens, through a different through the ether energy lens.
Right. So that's what I guess I wanted to ask you about is how you describe that different lens, because it seems like it can lie across all these different sort of areas where there's been plug variables or plug theories.
Well, if you go back to 1905, you say, okay, there's an ether energy, and the atom is being powered by drawing in that energy. You start there. Now you get up to, okay, there's a proton and a neutron. 1932 test, experiment using really crude tools. They got a proton and a neutron. They conclude that proton and neutrons are two separate elements, two separate particles. No, they were simply observed in different states of charge. The proton and neutron are the same thing. One is charged, one is neutral. Okay.
Okay. That's an absorbing or powering through the ether.
Yeah, it cycles through, and you extend a little bit farther. What holds the nuclei together? Well, what can lock things together? A current locks things together. They get a bunch of protons, nucleons, in the nucleus of an atom. There's a current that runs through it. Can we measure that current? Yes, we can check what the frequencies are. We manipulate those things in our MRI machines. But you just keep going through it. Is the universe expanding? No, it's not expanding. Well, why is it? Why do we see redshift? Well, what else causes redshift? Well, wind blows, the medium moves. An object is between you and the source. We interpret it as it's moving away from us.
Yeah.
It's not. So the really hard thing is it impacts almost everything that we've taught our people.
Yeah.
And the disruption was massive. It's something we have to do, or else 50 years from now, my kids are going to look around and say, God, that doesn't make any sense.
Or we're still asking those questions and we still had no answer to.
Right? And we've been doing that for a long time now.
Yeah. No, I think that's there's going on right now, and I think I'm going to raise the AI topic, but in the sense that I think that there's so much going on that the information overload is so massive that I think it's going to be interesting to see how some of the processing that could be done using AI might actually lead to more critical thinking or opening up some of these conflicts, across different disciplines and so forth. And I don't know if that's a rational expectation or not. But
the limitation of AI in any computer system is it's dependent upon the assumptions, the data, right, is based on. The problem that AI has today in dealing with physics is every bit of information that's in the mainstream is the current paradigm. So an AI system will fail for the same reason that a brilliant physicist will fail, because the solution of it trained in the same way. Yeah, the solution of the problem is outside of the solution set that they believe is their limitations. So I think if you give AI a new paradigm and get enough training, and then have it go look at all the theories. Here's one lens, here's another lens. You might be able to make some real progress.
Yeah, I think that's what I was thinking in somewhat, that there's maybe ways to use all of the work that's been done starting back in the 20s or earlier, and understand sort of that there are multiple, but specifically create that training model that suggests there are multiple, and then be able to then start bringing up that information in a way.
And that takes an enormous amount of discipline.
Yeah.
To back that
Well,
up.
it takes somebody who's actually going to be thinking through that and really looking for the answer that is different than what's out there.
It's interesting, my conversations with physicists become so defensive so quickly. It's the dismissal. That can't be true because, the sun's a giant ball of hydrogen. Well, it's not.
Yeah.
It's not a giant ball of hydrogen. That theory conflicts with about 7 other theories about the Big Bang and the creation and the sequence of events after the Big Bang, and then stars growing so fast and supernovaing, and it's just, there's so many theories that conflict with the sun being a big giant ball of hydrogen. But because they couldn't explain the sun's luminosity, that's what they fell onto. And then that tossed us down the road of nuclear fusion, cold fusion. Can we do it on Earth for unlimited energy? It's a compounded error. And, at some point, you got to break the paradigm and get a clean sheet of paper and really do a self-analysis.
I think the clean sheet of paper is always the hard part, right? Yeah, because people were in the institution, they have to make their case for their own personal goals, careers, whatever, and it's not too many people who can afford to say, I'm just going to sit down and start over, unless they are trained and they understand that maybe that training wasn't complete or was incorrect, and are willing to check off those alternative paths.
There's an enormous community of disgruntled physicists. A lot have been excommunicated from the Church of Einstein because they disagreed with the status quo. And there's a ton of them out there. And at some point, they just need something to rally around. There's enough of them who are trained, who know that the current model is wrong, and if they could take this model and look at it objectively, and if they can improve on it, fantastic. But recognize it is a paradigm moment, and we got to get on with it, because we're wasting time and human and capital resources. But my hope is that this message gets to the university level physicists who are heading into a PhD physics program, and allows them to ask questions and not be forced to accept just because.
Yeah.
It's not okay to say why, and then the guy says, I don't know. That's not okay. The beautiful thing about a theory is you don't have to prove it right or wrong.
Yeah.
By definition, it's you can't be proved. You might as well have one that's logical and works.
Yeah. Well, I think the idea that somebody who's going into the field can actually make a change, make a difference, make a name for themselves, and advance, the state of the art, by doing something a little outside that box. I think that just seems like that, would be an attractive opportunity.
That would be, they need air cover. They need someone that would, force the professors to allow people to go outside of the box and take in some of the really...
So to get a thesis accepted into the program, to get funding for their research, get, the kind of experimental opportunities to, to actually make some of those observations that might help to take a different path.
Yeah, the really interesting thing is, one of the interesting things is there's a lot of people screaming, including on the inside, hey, things are really wrong. You can't throw the theory away and have nothing. You cannot have a void. You've got to have a replacement theory, like Einstein's theory replacing Newtonian physics. Right. Now, it could be right or wrong, but in order to advance, you need a replacement theory. So all the people that are banging their heads against the wall, including me, saying, hey, this just doesn't make any sense at all, that can be productive if they can say, this makes more sense.
Yeah.
You got to have a positive outcome.
Yeah, exactly.
And I think that if you look at the ether energy theory, you will see that it addresses every observation. It gives you a simple, complete answer using logic that scales directly from the behavior of the atom to the behavior of objects like the Earth, the sun, to a galaxy. Unified, and it works. The challenge is it's incredibly disruptive.
Well, and I think part of that is, when you say it works, I mean, that's the kind of thing that, the young minds or the renegades, right, need to pick up and say, well, I'm going to show if it works, right? Yeah. Because basically that's what needs to happen, right? Across each of these areas where you've expressed the concern that the physics models and the math don't actually make sense
or
conflict
or show why it doesn't work.
Yeah.
But in order to do that, they got to get outside of the little box.
Exactly.
And I think that, and they're not going to get outside the little box unless enough people are screaming, hey, why is this wrong?
Yeah.
Why is this wrong? How come yours is better than this?
Right.
It's not. But enough people do that, these kids will be freed up.
Yeah. And
that's what we're trying to do here. And what's interesting is I get so much feedback online about, you think you're smarter than Einstein. No, and I don't think Einstein was smarter than Aristotle or Plato or Newton. We have different observational perspective based on time and history
and technology.
And I'm not smarter. I am just willing to use life experiences to look at the world slightly differently.
Yeah, and you're looking for people who are smarter
Right.
than you to actually carry that.
I would like to give them a tool that they carry forward and do things that I am not capable of doing. And that I think is how we'll advance. My only goal in this whole exercise, there's no financial benefit to me. It's simply to provide air cover to fix a problem that has been festering for 50 years that needs to be addressed.
And I've always been fascinated by this from the standpoint of, okay, since I'm the engineer in this discussion, it's like, what do we do with that? Right?
And you know something, you're smarter than that. You'll figure it out.
I won't do that, but I would love to see that some of the people who pick this up actually take it and look at it from the applied physics or the engineering standpoint and say, well, what do we do with that? Because there's so many fields right now that are pushing the boundaries of whether it's energy or chemistry or biology or life science. I mean, it's basically those things are all potentially going to advance if you actually can say, oh, we're answering some of these other questions, but people say, we don't know.
Here's a different way to look at this system. It's unlimited clean energy. Unlimited. How you harvest it, I don't know. It is door hard.
Say that. You can't say that. I don't know.
I don't know. I want them to figure it out.
Yeah, exactly.
They say this with every paradigm. It is incredibly disruptive, but it's by far the most exciting time because it's after a paradigm shift. Great advancements are made, and we have been bogged down for way too long. And one thing I'd like to talk about is particle physics. I'm going to use particle physics as an example of being failed by theoretical science today. We have been investing heavily in positronal research and our super colliders for a long time, and we have gotten little or nothing out of it. We can't see what's happening. We run objects into each other. They blow up. The parts of them disappear. We make the colliders bigger so we can run them into each other faster, and there is nothing coming out of it. At what point will someone finally say, hey guys, maybe this is the wrong thing to be testing? When do they raise the white flag? They don't ever raise the white flag. Nuclear fusion is the same thing.
This institutional issue is, I think, certainly got to be a piece of this. And I'm not saying there isn't research that's coming out that they have some value. I all know that once you built, $1 billion+ facility, you're going to pay, 10, 15, 30% annually or 100% annually in order to keep it going and continue to do the work that was originally chartered to do. And then, that sort of propagation, survival insake of that entity is going to continue to keep it.
You've got tens of thousands of trained physicists working on them. Yeah. And if they raise the white flag and say, oops, maybe we're looking in the wrong place, they're not going to self-correct. They can't. We have to force it. And, it's going to take a lot of people saying, this is not satisfactory. This is not. This is incomplete. This is wrong. Answer the questions. And once that starts happening, it opens up again.
I think there's a chance that not necessarily destroying it, turning it off, mothballing the whole facility, but repurposing it.
Yes.
You think repurposing is an option?
Absolutely.
So that's what you need to do, right? Somebody needs to say, look, I want to take an alternative theory and I want to use this wonderful equipment and this free investment to ask a different question and answer a different.
Yes. Most all of it can be, most all the investment can be retasked. It'll be in a very different way. And the retasking is going to take some really smart person to look at the new theory, look at the capabilities of the research projects, and rethink and test. They smash things together. If you track the way they got to where they are today, why they think that all of these 200 particles they've discovered after the collisions are there, that disappear in 10 to the minus 14 seconds, it's a conservation of energy law. Because they don't have an energy state that energy can go into, other than the ones that are defined by the current model.
Right.
And you add the ether energy in there, those things are the stability of a proton, and so they hit each other. The particles, it's like a firework going off. and they burn through it and they disappear back into a clear state. The energy is transferred. Conservation of energy law is correct if you extend the definition of energy to include a new state, a massive state. But again, it gets back to institutional issues, and I guess it always comes back.
But I think this is, I mean, this is not my field, so I am way out of school even thinking through this stuff with you. But I think if you listen to that explanation, it does have a certain sensibility, and it's logical. It does, exactly. So, what experiment would a really talented physicist who understands what a supercluster can do, what experiment would they propose to evaluate that particular theory? I don't know. I'm not asking you a question about an answer, but I would love to have somebody say, well, I mean, this is what I would do if I were to try to, basically cast that supercluster to do this experiment and see what kind of observation it would get.
Yeah. I think that they could find stuff. The Xeno labs, you get an incredibly sophisticated laboratory buried under an enormous mountain in Italy. They're looking for dark energy, dark matter. They're not going to find it there. But there are other things they can look for. You can look for what happens to the gravitational wave that's coming through the surface of the Earth as it approaches objects that are deep below the Earth. You put the same equipment in the bottoms of these giant mines that have been built, and you will see a drop in energy state as it goes through the crust. But anyway, I agree. If it was the investment for people to use. It's not a wasted investment.
Yeah.
And by the way, the guys who did it are incredibly smart.
Yeah.
And the poor researchers got sent off in the wrong direction. What I'd like to do is retest them.
Yeah, no, you got. I think the engineering went into it. I think the value that's come out of it, it has been huge. But I think the idea is it's not getting to the answers, and that you were originally asked to find.
I would say, if I were them, I'd step back and say we are incredibly successful. We have just disproved the need for the entire field of particle physics. We had to test it to exhaustion, and there's nothing there. So now let's go to someplace else. That would be to raise the victory flag.
Right.
Finding something proving something not true is just as valuable, potentially as valuable. Absolutely, it is true.
Absolutely.
Oh, absolutely right.
I mean, that is the basis of science. Yeah, the absolute basis of science. Yeah, I think if that investment is recast and repurposed, or at least augmented with additional purpose, right?
Yeah.
To find some of these other observations that would help to explain or use a theory that's alternative, I think that would be fantastic.
That would be, and possibly something hot.
Yeah.
You're not.
Yeah, I'm worth it. Listen.
No, I think that.
No, I meant in a positive way. This is the kind of message you're trying to get to the people who maybe want to grasp for that new idea, and have an opportunity to make a difference.
They just need a core platform. Yeah. And go prove it right or wrong. But if you prove it wrong, come out and say it's wrong, and then move on to the next shiny object. But don't just keep plowing ahead without any interest in changing directions,
right?
Which we've been doing. Let's see, another subject that is of interest. Here's the second ago. I will make a list of all of the flawed experiments that we keep investing in and getting no better results. You can fusion, dark matter research, particle physics, null results, but that's the vast majority.
What was the xenon, the gravitational research?
They got a incredibly sensitive piece of equipment down below a mountain, and they're looking for dark matter, and they think dark matter exists as to pass through, and based on the theories of dark matter, they tune this thing up to look for it. And they've been doing it now for a long time, and had nothing. But they just went back and refunded it for billions of dollars. At some point, hey, no dark matter. If 80% of the universe is different than we think it is, and we can't detect it here, that's a flawed theory. And if that's a flawed theory, that means Einstein's gravitational theory is flawed. If that's a flawed theory, then we got to go back and figure out what causes gravity. Right. And then you start having breakthroughs.
Yeah. Well, it seems like that would be observations in that facility that would be very useful if you just thought about things differently.
Yeah. Look at different things. Yeah. Retest.
So question I have is, from the first time he talked about you, Larsh, it was, this is one of my best friends, business partner, like I've known him for a really long time. I trust him with my life.
Never said that.
What is, and Cree has described this epiphany process a couple of times to me in different ways. But this is the first time that, other than Jen, that I have someone who's like an official friend and your business partner. How did that evolve and roll out, and like how did he disclose to you, this is what I'm thinking, and were you on board immediately? Like, at what point did you start like saying, hey, my friend Cree's got a really interesting point of view here on something?
He's gone off the deep end. And so I can't say for certain, but I would say that it was probably when we had first started living in the San Francisco area, shortly after college, that we had a sort of discussion of what at that point you called, the fourth or fifth dimension, right? I mean, it was that dimensional metaphysical type conversation. And I always remember how you had tied that to your mother's death back when we were in college. And so that's a persistent theme that I heard from Cree, sort of throughout the times we worked together. The interesting correlation on that is my wife is similarly sort of metaphysically interested and has had, experiences where she also feels that there's a lot more than most people feel or experience, and got into some things that, had some material scientists and physicists actually working on various things that were related to a metaphysical sort of thing. So there was this kind of interaction model there that we had through the time we were working. But I will say that the epiphany or the download, as I heard also people describe this kind of thing, is something that I didn't know till after we had done working together. In other words, not that long ago, maybe eight years or something. But it was something that sort of was the progression of a theme throughout the time that we worked together. When we would have conversations that would get into that sort of area, Cree would share some of his thoughts about the another dimension and where things were going. What I hadn't heard though was the tie back into physics. And I think when you were working with Cynthia was kind of when we sort of started really having more details around some of the real physics, and the science around what you've been doing, and tying that back to what you had come to understand through your epiphany. So that was after we weren't really technically working together, but we're just good friends.
Yeah, I think that the epiphany happened long before I knew much about physics. And the whole picture was clear to me, but I didn't know if it was absolute bullshit or not. Is something going to pop up that's going to disprove this thing? And boom, so it was developed to try to understand the possibility of there being life after death, to answer some questions about my mother. I couldn't take the faith pill. It made no sense to me whatsoever. And traditional physics had no on-ramp for metaphysics. So when I first got the epiphany, it took me 5 years of research to get to a point where I was comfortable to talk to other people. I was afraid if I want to talk to you and I said, hey, here's the idea, there's this energy ether, it interacts with matter this way. And you said, no, Cree, that's not how it works because of this. And then it's like, okay, my model is shattered. Yeah. All the stuff that was in my head that made me so comfortable has now been disqualified. So it took me a long time of research with a PhD physicist and access to the full Stanford Online Library to reach a point where I was conversational.
Yeah.
And that,
And I remember when that was going on, and I think, you know, I first of all, I would never say that I thought that your ideas weren't interesting and relevant to really trying to understand this stuff. And I think, you know, I've always also agreed with the idea that metaphysical and physics and sort of the whole notion of the universe and how does it work, that has to tie together in some way. So I think I was always very comfortable with that part of your thesis. I think the details around ether and the details around how you and Cynthia trying to, you know, think through some of this stuff, and then the length that you'd gone to research all this, that was the part that was like, wow, I had no idea.
yeah, my view on all of that is the whole purpose of this is to try to understand consciousness, purpose of life, and the potential for life. That's the entire. But as you said, if there is a purpose and there is a reason for all of this happening, there must be some tie into the physical behavior of the universe. It can't be completely separate. And so the entire model was built on trying to integrate metaphysics, consciousness, and physics. You sort of need to start with physics. You got to correct the physics stuff in order to start leaving the potentially being labeled a Looney Tune.
Yeah.
Because there are a lot of people out there fishing religious options and so forth, and that's not what I wanted to do. So the massless energy, the only other example of massless energy is organized massless energy, which is consciousness. It is real, but there's no substance to it, you know, and you can create things out of the blue. And so that was the overlap there. And then the whole metaphysics thing is it's a interesting binary question. If you're a nihilist, you know, we go to the dirt and we disappear. I think that there is something more. Again, I couldn't take the faith pill because there was too much, in the 60s, there was too much contradiction in watching my mother die slowly and painfully. So that sort of conflicted with a lot of religious options, and the physics had nothing. And then the epiphany started coming, and they kept coming and coming and coming, and I couldn't stop it or make it happen. It just happened, which fits in with what I ultimately came to believe, which is there is something a lot bigger than we are. I don't necessarily think it's God. Maybe there is an evaluation that goes on after it. It doesn't matter, it's a personal decision. But mine is, there is something more. And if I'm wrong, I'll never know it.
Yeah.
So might as well be positive.
No, I think I think it's interesting because, you know, over the last several years, you know, people say, well, so what's free at to, you know? And, you know, I began to go through, you know, a little bit of that sort of explanation. I said it all started, you know, back when his mother passed. And I think then it's like, it's very easy to say. And if you start exploring that in any kind of detail, you get into the physics, right? And it's just like, it's inescapable that you come to a conclusion that you need to understand the nature of the universe at a physics level in order to think about these things. And I think I've never had anybody question me about that, right? I think everybody kind of, implicitly gets that is a connection.
And I think everybody wants to have it be a connection. They don't get a hoot about the next particle somebody finds. They want to have answers to the big life questions. And again, that should overlap with physics, and it doesn't today. And that's why nobody cares.
Yeah.
Now, if we can reintegrate them, you know, there's some momentum. You know, we can really start to get stuff done. So that's the hope of all of this, is that we can create a platform to expand physics into things that actually had more value to us.
Yeah, no, I think, and we talked earlier about some of the more material things that I think can also come out of that. And I think that's just all about, you know, making life better for people and humanity. And I think there's a really powerful outcome of people starting to embrace this idea that we are blocked, right? And that we're in that box, and getting out of that box, you know, is going to be a major shift.
It's going to be a hell of a relief. Progress again. So the whole idea, we have a lot of information about the potential for life after death. Relevant, statistically important information. You're white to somebody who's having extraordinary experiences. You know, Beethoven wakes up with an entire concert or entire symphony in his head. Musicians all the time have these epiphanies, these great things come out of artists. But we don't have any way of putting those things into a category and measuring them. There are some things we know about death. If there's life after death, one is still bodies don't go. Which leaves one thing. That's our consciousness, or what maybe religious people call our soul. That can continue. So in the model that's been built, we look at dimensions as being sequential, as being each dimension is a subset of the next dimension. I believe that there's a fourth dimension that we all are reborn into, or maybe reborn into. I don't know if it's going to be, if there's a struggle there. I know that the rebirth is going to be just as dramatic as pulling out of the womb and having to breathe air into your lungs. And the learning curve may be as great as learning how to speak and walk and move your arms and this. I don't know for sure. But the people who had near death experience, and the vast majority of them don't want to come back. And that's very encouraging. Even when they do come back, they're different. And that includes the researcher I work with, Cynthia Husted. There's another thing that I think is really important in the dimensional shift. And that is that when you have something you cannot deal with, like in our case is linear time. The Big Bang is popular. It says, everything popped out of the Big Bang, everything started right then. Everyone says God. Well, if you have linear time, you can always subtract 10 minutes from any point. So in order to deal with the beginning at the end, you need an observational perspective that's different than where we're currently sitting. So I think in the next dimension, life can exist without an organic structure. It has to. And in that life, time is not linear. That is a really hard thing to wrap your head around, because everything to us is start, finish. But if time is not linear, you ask the question, what started everything? The answer is, there was no start. It doesn't need a start. Start is something that is so simple at that level, but from our observational perspective is really challenging. So in my model, where I think we're going is we evolve, we've actually selected for the development of consciousness, survivable consciousness. Did dogs survive? Don't know. But I think that in my model, I think that the brain has got to get to a certain point where it can abstract the world for itself. It can evaluate itself from the outside. I think that's unique to humans. So that's sort of the model of life after this for me. If you swallow the faith pill, God bless you. That is a really.
Those don't seem inconsistent. One of them is just sort of a structure for thinking about some possibilities.
Yeah.
And the other is just, I don't need that structure.
Yes.
Right.
And I am jealous, because that's one huge thing that just gets removed from your variables process as you try to make your way through life.
Yeah.
If you believe that, Allah is going to reward you for certain things, life can be pretty simple.
Or if you behave in certain ways, you will have a better future.
Right.
In whatever's next. Right.
So any of those are fine. But for me, I needed something that integrated with what we're doing here. And there's too much conflict in my life experience with a lot of what they say in the religious teachings.
Yeah, I think there's also I think the evidence is cited all the time that there's, as opposed to a mass hysteria, the lore and the history and the tradition that is passed down in religions of all types, are so similar that there has to be a common experience across humanity that says these things are not just inventions. There's experiences that have led to people all over the world, different religions, thinking these are for common.
Yeah, I think it's really important that everybody has something. Unless you're a nihilist, I feel sorry for you. But it's hope. We need to have hope. But anyways, that's sort of the transition I had to get into where I am now, and that's something that I don't talk much about, because in order to have a serious conversation about that with a scientist, we need a different paradigm in physics. It's got to be able to integrate in, and there's impossible to integrate into the model we have today.
Yeah.
So they've shut that avenue off, and I think it's really important we reopen that.
No, I think it's exciting to see all the stuff that's going on between quantum computing and AI that are thinking through things that are now approaching the idea of consciousness. Yeah, right. From an artificial standpoint, or just the issues of what quantum was all about, and the uncertainties that are associated with all the math there. So it's really, I don't know. I think I've started to see more writings about that kind of thing that tie back to your belief that there's a inherent need to have those tied together.
Me too. 'Cause people actually care.
Yeah, well, I don't care. That's the kind of thing, more people talking about it and more people thinking, okay, does this fit with my research thesis or in the way I want to path it
And a
about it?
boatload of the creative physicists that get their PhDs that are so disillusioned by the physics industry and what they've learned, and they end up at Google and they end up at these AI companies. They're the creative ones that are really, really, really smart. And hopefully with the right paradigm, they can make breakthroughs that we can't even imagine today.
So I think there's a lot of these things are mind scratching all over the place. It's fun. It is fun. I think it's certainly by the time the next generation is in the midst of their career, we're going to see a lot more of these answers.
I hope so. Hope it happens before I die.
Me too.
If I go first, I'll try to reconnect. But
You'll be cycled right back.
some people go, they don't give it. Don't.
Well, maybe your purpose is actually to cycle back through and be the next.
One more thing is to say, Mitt, we look at the experiences, the near-death experience, the people that near-death experiences, and this feeling of love, and of lightness, and all of that. My theory for that is we develop certain things, baggage here, emotional baggage, hatred, jealousy, lust, lots of different negative things that have been very beneficial for natural selection. And when we die and our bodies go away, we don't have to reproduce. We don't have to feed ourselves. If we're not breathing or dying, it must be a wonderful feeling not to have to carry all the garbage.
I agree, and I think that we often kind of call that stress.
Yeah, it manifests itself as stress.
Exactly, and I think stress is a killer for all these various physical reasons. It's also a weight emotional, and it's a barrier to the kind of feelings you're talking about. Yeah,
I think that Buddhist monks, there's some people that can meditate their ways into the next level, who are much more advanced than all would be. But yeah, drugs, great. Drugs can shut down your consciousness and let you go places. The downside is that it can also burn out your brain and turn you into a veg and cut down the connections. The drugs have been fabulous recently.
see, that's what happened to us.
We did enough. Too bad booze doesn't do us. They don't work done plenty.
No. So you were talking about this dimension, these actual multiple dimensions that we live in today that we experience as being linear time, and that the idea of a fourth dimension was one where there was no linear time. How do you get your head around that? That's a bizarre topic.
So if you want to look at this thing scientifically, you need to be able to answer the basic questions. And one of them is, what started everything? And that's something that's impossible to answer within the confines of the laws of nature of our dimension, the third dimension, which has linear time as a fix. It's not variable, it's not optional. When you need, one of the things that, again, projecting forward, then in the fourth dimension, the two things that get relieved is you don't need a physical structure to support your consciousness. And the second is there cannot be linear time. You've crossed the dimensional boundary. Once you get to the other side, and your observational perspective is from there, and you look back, and someone says, hey, what started everything? It's like, well, that's kind of a dumb question, because there is no beginning, there's no end. Time is not linear. So from the observational perspective of the next level, that is a non-question. Much in the same way, if you're in the second dimension, you're there with your buddy, and your buddy says, hey, let's jump. You cannot jump. That is a law of nature of the second dimension, which is the plane. There is no depth. You go to the third dimension and say, hey, let's jump. Of course you could jump.
Yeah.
And it's the same thing where something that's impossible at one dimensional level is relaxed to define the next dimensional level. And this is simply personal theory, but those are the things that need to be relaxed in order to sort of wrap my brain around begin to construct what I think life might be like at the next level. But again, I think that there's something there, and there's a lot of people who've experienced extraordinary things.
Yeah.
I can't explain. I woke up.
Well, certainly the religious, no beginning, no end concepts are pretty pervasive as well. So I think, that's interesting that, again, that over time, societies have evolved those kinds of constructs, in their belief systems in some ways. It doesn't get specific like you have, which is basically it's a dimensional thing. But it essentially does say that, hey, there's something different than this world that we live in, and it's different enough that you're outside of it.
If you track, religion's fantastic in that, all the way back, thousands of years, if they couldn't explain something, it'd be assigned to a god or to some religious solution. So you had an answer. You could answer all the questions because the construct was there for you to believe it. Over time, a lot of those things were removed from religion and brought into science. And the transfer from religion to science happens over time. And once it gets into science, you can answer the questions within the construct of what we understand. The stuff we don't understand is still off on the religious side.
Exactly.
And I'd like to see those two things merge. The religious theory along with the physical behavior of the universe.
Well, and some of that I think would start to address some of the questions that people, you talked about redshift and expanding universe. Well, some of that would actually be, consistent with saying, look, maybe that's not the case. Maybe it's not an expanding universe that explains this. And, that then does, sort of make some of the issue of a big bang and sort of a start, less important.
Tell you something I haven't talked to you about, but it's really been fun for me, is we went back and we did all the research, all the way, I didn't do it, but Cynthia did it, all the way back to the original, Einstein's original papers. And you ask the question, where did that come from? And you go back and you look at what started the Big Bang. It's something really trivial. It's something small. It's like, what started the expanding universe? It was something small. And then it just grew. And so you go back and say, you got to be kidding me. That's the observation. That's the question you're trying to answer. And we ended up with all this goop. Everything came out of the 1930s. It was 20s and 30s. And it just, things piled onto it. Now we have this amorphous structure of fantasy theories that we're stuck underneath, trying to dig our way out.
Alternative explanations, that's what you need.
I got to
The other way to think about it.
I got to. And that's something I'd love to do at some point, is just, I need someone to represent the consensus model. I can use Wikipedia or something online or AI, tell me what the current theory of gravity is.
Right.
And have that, and then I want to compare and contrast the two.
Yeah, I think that would be really useful. I think being able to actually offer at least a glimpse into the potential for the alternative, right, using the construct of ether and some of these other things, and say, okay, if we believe that, then this is how I would explain gravity, magnetism.
And then you tell me what makes more sense to you.
Right.
It's just this complete abandonment of logic in lieu of math is just mind-boggling. To be a physicist, you have to be a mathematician. It's really interesting, and we've basically ceded control of the physics industry to mathematicians. And the goal of a mathematician is to make the math work. It's not to explain anything to anybody. They don't explain anything. To make the math work. The math works. Hey, let's go. Let's keep moving. And that's got to change. Logic has got to be reinstalled as the guiding light for physics theorists. And that hopefully that'll happen soon.
Glad you're working on it.
It's fun. Yeah, Larsh, I really want to thank you for coming out here. I know it's taking time out of your busy day, but it is fun to talk about this stuff, particularly when we go back and look at some of our history together and how that affected me in the evolution of it. But as we wrap up this podcast of Beyond Einstein, we'd love to have you come back sometime in the future and dig deeper.
No, you do, and it's always stimulating to be thinking through these things. And I do fundamentally believe that there's some massive opportunities if we can crack this code a little differently and come up with some answers for many of these questions.
See, that's what the engineers care about.
Yes, I reckon I want to do something with it. Hands on, get
Applying it. And I think you will. I think things will become very.
Well, you better hurry it up.
It's not my fault. I'm the one slowing things down here. Anyway, appreciate your time.
Yeah, appreciate being able to have the conversations.
Join the conversation at beyondeinstein.org.